What is different between REST API and RESTful API? REST API and RESTful API are terms often used interchangeably, but there is a subtle difference in their meaning. REST API. This term simply refers to an API that follows the principles of REST, representational state transfer. REST is an architectural style for designing networked applications, particularly web applications. REST APIs are designed to be stateless, meaning each request from a client to the server must contain all the information needed to understand the request, and the server cannot store any context about the client. REST APIs typically use standard HTTP methods, GET, POST, PUT, DELETE, and adhere to RESTful principles such as resource identification through URIs and hypermedia as the engine of application state, HATIOs. RESTful API. This term is used to describe an API that conforms to the principles of REST. In other words, a RESTful API is a REST API. It is designed to be resource-based, stateless, and use standard HTTP methods. It aims to provide a uniform interface for interacting with resources on the web. In summary, the main difference is in the level of emphasis. REST API is a general term for any API that follows REST principles, while RESTful API specifically emphasizes that the API adheres closely to those principles. What are the advantages of using REST in Web API? Using REST in Web API offers several advantages. Simplicity and uniformity. RESTful APIs use standard HTTP methods, GET, POST, PUT, DELETE, and follow a resource-based architecture, making them easy to understand and use. This uniformity simplifies development and integration with other systems. Scalability. RESTful APIs are stateless, meaning each request from a client contains all the information needed to process the request. This makes them highly scalable, as servers do not need to maintain client state between requests. Flexibility. RESTful APIs allow clients to interact with resources in a variety of ways, including retrieving, updating, deleting, and creating resources. This flexibility makes them suitable for a wide range of applications and use cases. Performance. RESTful APIs can be highly performant, especially when combined with caching mechanisms. Since RESTful APIs use standard HTTP methods and status codes, they can take advantage of existing HTTP infrastructure for improved performance. Separation of concerns. RESTful APIs promote a clear separation between client and server, with each responsible for its own concerns. This separation allows for easier development, maintenance, and evolution of both the client and server components. Interoperability. RESTful APIs are based on open standards, such as HTTP and JSON, making them interoperable across different platforms and programming languages. This allows for easier integration with third-party systems and services. Visibility and debugging. RESTful APIs are designed to be human-readable, with resources represented as URLs and actions represented as HTTP methods. This makes it easier to understand and debug API interactions. What is REST and SOAP? What is different between them? REST, representational state transfer, and SOAP, simple object access protocol, are two different architectural styles used for designing web services. Here's a brief overview of each. REST, representational state transfer. REST is an architectural style that uses a stateless, client-server, cacheable communication protocol, typically HTTP. It emphasizes the concept of resources, which are accessed and manipulated using a set of predefined operations, HTTP methods like GET, POST, PUT, delete. RESTful APIs are designed to be simple, lightweight, and scalable, making them suitable for distributed systems and the web. SOAP, Simple Object Access Protocol. SOAP is a protocol for exchanging structured information in the implementation of web services. It uses XML for message formatting and relies on other protocols like HTTP and SMTP for message transmission. SOAP defines a set of standards for message structure, message processing, and communication protocols, making it more rigid and complex compared to REST. Differences between REST and SOAP. Protocol. REST is an architectural style that uses HTTP as its communication protocol, while SOAP is a protocol that can use a variety of communication protocols such as HTTP, SMTP, or JMS. Message format. REST typically uses lightweight data formats such as JSON or XML for message payloads, while SOAP uses XML exclusively. Complexity. REST is generally considered simpler and more lightweight than SOAP, which can be more complex due to its adherence to a strict set of standards and protocols. Flexibility. REST is more flexible in terms of message formats and communication protocols, making it easier to integrate with other systems. SOAP, on the other hand, is more rigid but offers features like security and transactions. Caching. REST APIs can take advantage of HTTP caching mechanisms, improving performance and scalability. SOAP, being more protocol-driven, has limited support for caching. Statelessness. RESTful APIs are stateless, meaning each request from a client contains all the information needed to process the request. SOAP, on the other hand, can maintain state between requests using sessions. In summary, REST is often preferred for its simplicity, flexibility, and scalability, while SOAP is used in environments where strict standards and protocols are required, such as in enterprise applications. What is Web API 2.0? Web API 2.0 refers to the second version of ASP.NET Web API, a framework for building HTTP services that can be consumed by a variety of clients, including web browsers, mobile devices, and desktop applications. Web API 2.0 was released as part of the ASP.NET framework and included several enhancements and new features over the original Web API. Some key features of Web API 2.0 include attribute routing. Web API 2.0 introduced the ability to define routes using attributes, allowing developers to have more control over the URL patterns used in their APIs. Cross-origin resource sharing. CORS Web API 2.0 added support for CORS, which allows web applications to make cross-origin requests to APIs hosted on different domains. Improved OData support. Web API 2.0 improved its support for OData, Open Data Protocol, making it easier to create and consume OData-compliant APIs. iHTTP Action Result Interface. Web API 2.0 introduced the iHTTP Action Result Interface, which allows developers to return different types of HTTP responses from their API controllers. External authentication providers. Web API 2.0 added support for external authentication providers, making it easier to integrate authentication with popular identity providers like Google, Facebook, and Twitter. Attribute-based authorization. Web API 2.0 introduced attribute-based authorization, allowing developers to easily restrict access to their API endpoints based on the roles and permissions of the requesting user. Improved tooling. Web API 2.0 included improvements to the Visual Studio tooling, making it easier to create, debug, and deploy Web API projects. Overall, Web API 2.0 was a significant update that added several new features and improvements to the ASP.NET Web API framework, making it more powerful and easier to use for building modern HTTP services. Explain media type formatters. Media type formatters in ASP.NET Web API are components responsible for serializing and deserializing data between .NET objects and the raw HTTP message body. They handle the conversion of objects to a specific media type, such as JSON or XML, for responses and convert incoming request data from the same media types into .NET objects. Here are key points about media type formatters. 1. Role. Media type formatters play a crucial role in Web API for formatting data in the request and response messages. They help ensure that data is transmitted in a format that can be understood by both the client and the server. 2. Content negotiation. Web API uses content negotiation to determine the appropriate media type formatter based on the request's accept header. The formatter selected is responsible for serializing the response data into the requested format. 3. Built-in formatters. Web API includes several built-in media type formatters for common formats like JSON, XML, and for Erlang-coded data. These formatters are automatically selected based on the request's accept header. 4. Custom formatters. Developers can create custom media type formatters to support additional media types or to customize the serialization/deserialization process. Custom formatters must inherit from the media type formatter class and override the can-read type and can-write type methods to indicate which types they can serialize and deserialize. Configuration. Media type formatters can be configured globally for the entire Web API application or on a per controller or per action basis using attributes or the HTTP configuration object. 6. Performance. The choice of media type formatter can impact performance, especially for large data sets. Using a binary format like protobuf or BSON can offer better performance compared to JSON or XML for large payloads. 7. Error handling. Media type formatters handle serialization and deserialization errors differently. For example, if an object cannot be deserialized from the request body, the formatter will throw an exception that can be caught and handled by the application. In summary, media type formatters are essential components of ASP.NET Web API that handle the serialization and deserialization of data between .NET objects and the raw HTTP message body, allowing for seamless communication between clients and servers using different media types.